Thank you, Roberto, and thank you also IVC to give me opportunities to present my work here. Today we will discuss about the topic ventilation system design and the risk areas for spreading airborne contaminants in office buildings. In this part, we will focus on airborne transmission from room to room. I mean, based on our study, we can state that even if buildings have well-functioning ventilation system, which it is in the case in most of Nordic countries, it doesn't mean that airborne infectious disease transmission from room to room could be avoided. The reason what I say this is because our study reveals that differences between risk area for spreading airborne contaminant office buildings in Northern Europe and the differences in the spread depends on a different ventilation design used in a different countries. First of all, it should be noted that the spread of airborne pollutants depends on air movement or airflow, and secondly, two prerequisites must be fulfilled for airflow from one room to another: pressure differences and leakage path. Pressure differences in buildings can be created through wind forces, temperature differences, and mechanical ventilation. I would like to mention that there must be a careful design of mechanical ventilation system to accomplish directed airflows in a building, whereas the pressure differences created by wind and temperature are considered disturbances. These two drawings that you can see here in the right side are showing that in principle, depending on the balance between the supplied and exhaust airflow, a mechanical ventilation system can create a pressure differences between the room and adjoining spaces, both outside and between these rooms. You can see here that we have two office room and one corridor. We have a plus in one figure, and we have minus here. It means that the air direction is from the room to corridors. And another figure show that you have a plus, 2 plus and 1 plus and minus. It means that the air from the one office can go to the corridor and from corridor to the next office room. Regarding the office building in northern country, that I will focus on that today, is that most of the new office building in northern country are equipped with balanced mechanical ventilation system. The most common solution in the office building are VAV system. The ventilation system should be able precisely control the indoor climate, or otherwise the target value of indoor temperature or carbon dioxide concentration may not be fulfilled. This drawing show a typical design of Swedish office buildings. The air is supplied to the office room and transferred into the adjoining corridor where it is exhausted. That was the here is one typical design of Danish office building. In this case, supply and exhaust air is installed in every room. But remember that in this case, equal volumes of air are brought into an exhaust of the building. Here is not question about room, it's a question about building. But in other cases, I mean, in another country was based on a room that I will show you. So it's a different design in different countries. Here is Norwegian, and Norwegian, I mean, a typical design of Norwegian office buildings. And in Norway, the most common ventilation system in new office building is balanced room ventilation system. So the balance is in the room, not only on the building. We have done a simulation study. The simulation study was with Modelica, and here we have office 1, and the source of contaminants is here in office 1. So you have a corridor here, and you have office 2 here. The zones were modeled assuming the complex mixing of air, and bidirectional airflow between offices, and the corridor was modeled using a door model with a leakage area of 0.02 square meter when the door is closed. So simulation was based on a closed door. The source of contaminants in this study was carbon dioxide. We have done a piece of work recently, and we show that there is a strong correlation between PM10 and carbon dioxide. In this table, I will show that in Denmark, you can see here we have supply ventilation rate here, and we have exhaust ventilation rate here, and we have airflow through the door. Denmark, we have 60 supply and in one office, and 30 in another office, and corridor is a 70 liter per second. For the exhaust is 45 because we talk about building in average, and for each room, and corridor is a 17. For Sweden, we have 60, 30, and 17, but because the corridor is the exhaust, so you have the sum of the airflow in a corridor. For Norway, we have 60, 30, 17, and you have in rooms level, you have the balanced mechanical ventilation system. So you have, of course, 60, 30, 17. And 15 here as a minus, it means that the air from the one room can go to the another room. Here is some calculation regarding the pressure differences when the door is open and when the door is closed. We go for the result of the calculation. As I say from the beginning, you have 2 offices and 1 corridor. The source is in office 1. And you can see here, that's a situation of Denmark, typical for Denmark. So we have 60 liter per second in office 1, and you have 30 in office 2, and in corridor you have 17. Because you have a exhaust ventilation is the average of the office 1 and office 2, so you have 45 here and 45 here in 2 offices. Corridor is a 17, is a balance. So you can see the concentration when you have the source in office 1. So the concentration is high, of course, is obvious, but you have transfer to the corridor. So the corridor is higher concentration, and you have in the next room, because you have average, and there is opportunities that so you see the concentration is lower here. So for Sweden, as I say before, You have in office building 1, you have 60 liters per second, office 2, you have 30, and corridor, you have 70. The exhaust is in a corridor, so 107 liters per second is in a corridors. And so you can see the source in office 1. So the concentration in office 1 is very high, of course, but you have in corridor the transfer is from office to office 1 to the corridor, so you have high concentration in corridor. But in office 2, you don't have any concentration of carbon dioxide. Regarding the Norway, so we have supply ventilation rate is a 60, office 1, 30, office 2, and corridor is a 17. So you have the same exhaust. So you see that the concentration is isolated in office 1, and it will not transfer to the corridor and office 2. So the conclusion is that the existing ventilation system of Swedish office building can contribute to spreading airborne contaminants from office rooms to corridors, but not to the next rooms. Airflow should be supplied and exhaust. That's maybe a measure that airflows should be supplied and exhaust from each room. And I mean, in order to avoid spreading the airborne contaminants to corridor. For a Danish case, so it is a transmission from the room to room, and actually the extracted airflow must be equal to the supplied airflow in order to achieve correct pressurization in the rooms. And for Norwegian, the existing ventilation system of Norwegian office building don't transfer the contaminants to other rooms. So it is the good balanced mechanical ventilation system. We have published this result in an article called Ventilation System Design and the Coronavirus COVID-19. You can find it for more information in this place. Thank you very much.